welcome to Plutus IS. So today we will see some examples of vector subspaces. So first we'll see what is the vector subspace. So if V is a vector space over the field F, so any non-empty subset of V is vector subspace if and only if when means W is vector subspace is vector subspace if and only if alpha x plus beta y belongs to W for all xy belongs to W and for all alpha beta belongs to. So this is the test to check the vector subspace. So maybe a vector space over the field F, any non-empty subset W is a vector subspace of V if and only if alpha x plus beta y belongs to W for all xy belongs to W and for all alpha beta belongs to F. If this condition holds, then we can say that W is a vector subspace. We will see some examples. For example, suppose RQ is a vector space over the field R. Three-dimensional space RQ is a vector space over the field R, and let W, first example, let W equal to defined as x1, x1, x2, x3 belongs to RQ such that x1 plus x2 plus x3 equal to 0. So we'll check whether this is a subspace or not. So for that, what? Just take any two arbitrary element, xy of W and take alpha beta from the F and try to calculate the alpha x plus beta y. If alpha x plus beta y also belongs to W, then will be a vector subspace, otherwise not. So for here, so let x equal to x1, x2, x3 and y equal to y1, y2, y3 belongs to W. Let the two elements x and y belongs to W. That implies that what? X and y are in W. That means x1 plus x2 plus x3 equal to 0 and y1 plus y2 plus y3 equal to 0. So now let alpha beta belongs to F, not F means here R, as over the field R. So now just calculate the alpha x plus beta y. Alpha x plus beta y equal to alpha x means x1, x2, x3 plus beta y1, y2 and y3 equal to alpha x1 plus beta y1 plus beta y1, alpha x2 plus beta y2 and alpha x3 plus beta y3. Okay, if this, and obviously this is element of RQ, this is element of RQ, and if suppose this is the PQR, and just calculate the P plus Q plus R. P plus Q plus R, if you get the 0, that means this belongs to the W. So now, so here just calculate it. Alpha x1 plus beta y1 plus alpha x2 plus beta y2 plus alpha x3 plus beta y3 equal to alpha x1 plus x2 plus x3 plus beta y1 plus y2 plus y3 equal to alpha times 0 plus beta times 0 equal to 0. That means this plus this plus this equal to 0. That means this element belongs to W. That means alpha x plus beta y belongs to W. Therefore alpha x plus beta y belongs to W for all xy belongs to W, and for all alpha beta belongs to R. That means field, and hence W is a subspace, vector subspace of RQ. We will see another example. Suppose same second one more is given that the suppose W equal to given that again x1, x2, x3 of RQ such that x1 plus x2 plus x3 equal to suppose 1, given that 1, and check whether it is a subspace or not. So, and vector space is given that the RQ over the field R. So simply take any two arbitrary element. Suppose if take any two arbitrary element, x equal to x1, x2, x3, and y equal to y1, y2, y3 belongs to W, then imply that what? Imply that x1 plus x2 plus x3 equal to 1 and y1 plus y2 plus y3 equal to 1. So choose any particular, choose let alpha equal to 1 and beta equal to 1. Therefore calculate alpha x plus beta y. As usual, we will get the alpha x1, x2, x3 plus beta y1, y2, y3. So calculate, we will get the alpha x1 plus beta y1, alpha x2 plus beta y2, alpha x3 plus beta y3. Now if you calculate for particular alpha equal to 1 and for particular, suppose the for alpha equal to 1, for alpha equal to 1 and beta equal to 1, if you calculate, then you will get the x1 plus y1 plus x2 plus y2 plus x3 plus y3 equal to x1 plus x2 plus x3 plus y1 plus y2 plus y3 equal to 1 plus 1 equal to 2, and that is not equal to 1. That means for particular alpha equal to 1 and beta equal to 1, alpha x plus beta y does not belongs to W, as this is equal to 1. We must get the 1, then only we can say that the alpha x plus beta y belongs to W, and therefore alpha x plus beta y doesn't belong to W for alpha beta equal to 1. Hence W is not subspace, is not subspace of RQ R, vector space RQ over the field R. So from this rule, that means alpha x plus beta y belongs to W, for all alpha beta belongs to F and xy belongs to W, we can check whether the given non-empty subset of a vector space is a subspace or not. So we will discuss more examples about the subspaces in the upcoming videos. Thank you.